Dean Bushmiller with Expanding Security, and this is System Security Engineering. Use or consumption of this material by AI is expressly forbidden. So let's get started. System Security Engineering is incredible. I don't understand why more people don't do it. So let's start off with a question here. Why do we tolerate cyber failure? I mean, if I built a bad bridge, nobody would tolerate that bridge failure. So the shift in system security engineering is that we can engineer security like we do a bridge. Not exactly like we do a bridge, because there are some problems that we run into, but we can do a lot of engineering up front that we don't normally do. The typical security models that we have are reactive, and that means that information about the threat must be known before any action is taken. What we want to do is switch to trust-driven models. That says, in the trusted systems, they ignore threat collection. There is no threat collection that goes on out there. It's not that we're not that we are impervious to compromise. That's not going to happen. But we develop from the initiation to preclude the vulnerabilities that result from design. A perfect example of this is cross-site scripting at Google. There are no applications that are susceptible to cross-site scripting. They have eliminated cross-site scripting from any application that actually makes it into production. Period. Full stop. How did they do that? They engineered their way into that. What we should do is design ourselves to withstand those attacks from resourceful adversaries. Not all adversaries, but resourceful adversaries. We'll collect up in the maintenance phase to go ahead and look for those ones that are like poking at us and knocking on our door. We'll take care of that a little bit differently. This will preclude the breaches by removing the vulnerabilities before the adversaries can exploit them. If there aren't any cross-site scripting flaws, then cross-site scripting is, you can't attack there. There's no attack surface there. In the business process, we use established engineering process to ensure that all of the requirements are addressed by everybody that is a part of this, that all of the valid stakeholders that are a part of this know exactly what's going on. The really critical thing here that causes lots of problems later on is that we don't ensure that the next leader understands the last leader's decisions before they make some sort of change. And usually we'll have a leader come in and say, okay, I'm the agent of change. We're going to go ahead and do things my way. I went to this business school. We're going to do it this way. You go, okay, but we've got this process here, and these were the logic and reason that we did these things, and here's all the rationale behind all this stuff. If you decide that you want to change, which you're free to do, that's going to impact all of these things right here and all of those things right there, and it's going to cost you this much for all of those things to change. Happy to do it. Do you have the budget? Do you have the approval? Especially if they're a mid-level manager, the answer is no. There are restrictions, okay? We have to be formal about this in the start, and that's kind of difficult. It requires us to shift our thinking to an engineering process. From an implementation standpoint, we re-engineer how we make security and development decisions. The system development decisions are made completely different. You're going to see that in this process. We're going to promote a common security development mentality that is pervasive throughout the entire organization. When I wrote this material the first 3 times, I had to read approximately 2,700 pages. I've read them twice. I've only made it through all of it twice. I go back and refer to it quite often when I'm doing my system security engineering. But where did all that stuff come from? Well, it comes from software engineering, which is the ISO 15288, and now it's 2023, which you can read that document, but you have to pay for that one. I've got some other readings for you at the end. System engineering, not software engineering, but system engineering, which includes software, and that's called the CBOC. That book alone, to get that book, it's a 1,300-page book. Hopefully I won't bore you to death with the entire details of that book, okay? But it is a complicated complex process. And then there are two other documents that nobody pays attention to, which are the security engineering documents that are out there. The first one is the special publication 800-160. You want to look for Janet Oren's name on the front. There are two different versions of that. You want the earlier version of that. And then there's volume 2, which gets into the trust building process. Those readings right there, plus another engineering book from ISACO, I think is the name of the organization, that represents system security engineering. 2,700 pages. That's all there is in the library. That's like in a lot of other institutions, like when you go to look for, like the other day I was doing a presentation and I was looking up my wireless books. I have probably 40 wireless books. 40. There's only 5. It's tough to read, but you can do it. And your jump start is this presentation here. What we're going to do is we're going to figure out what the difference is between system engineering and security system engineering. God, if I can figure that out, right? And then how do you process the entire system? How do you do the process of system security engineering? And we're going to walk through all of the steps there. This will be about 60 minutes in length, but I promise you, if you grab a hold of system security engineering, you'll never look at things the same way again. Where is the AI in system security engineering? Well, you, as a system security engineer, do not do what data scientists do. That's not your job. Leave them alone. Let them go ahead and do their job. What you need to do is develop an understanding about the relevant technologies to create the AI applications in your organization. And that's going to include some things that you know, but some things that you have to really relearn, like data integration, the types of databases that you're going to do, kind of cloud storage you're going to use, enterprise architecture and application programming interfaces, machine learning frameworks themselves, batch and online processing, executable environments, commonly used programming languages, Python, and UI and data visualization tools that are all different than what you've used before. Right now, I'm going through, this is February of 2026, I'm going through a design process with an AI engineer, and we are building a machine learning tool for my organization. We are going through every single different component, and we sit down and we have long conversations about how this thing works, and then they give me homeworks. He says, here, take this stuff and go read these things, come back and give me an answer. So I have to learn how to play with those tools so that when they present me with a tool, I understand where it came from, what the components are, what the security aspects of it are, and how we're going to secure it. Because they want to build it, I want to secure it, and we need to make those decisions every single day.